and welcome to this session on zero force members. In my lectures, I explain what zero force members are and why they're needed, but in this session, we'll look at the practicality of finding those zero force members. So we'll first discuss the three cases where we can immediately identify zero force members, and then we'll go on to look at some examples. Let's get to it. So the first case for zero force members is when you have an unloaded joint with only two members. This will typically be a corner joint in your truss. Okay, so important, note here that these two members are not collinear, so they're not on the same line of action, they do not have any external loads, and they're connected at that joint. Let's see what happens in this case. If we look at the sum of forces in the y direction, we can see that there's a component of n1, so n1 sine theta, the angle, which has to equal 0, right? Because this joint has to be in equilibrium, as does every other joint in the truss. Now, this means that since the angle isn't 0, n1 has to equal 0. And if n1 equals 0, when we come to do the sum of forces in the x direction, we get a component of n1, which we know is 0, and we get n2. Because n1 is 0, that means that n2 is 0. So that is the first case, an unloaded joint with two members that are not collinear. Now you can probably see here that this comes out when I do the method of joints, so I can see immediately that everything equals 0. However, if I identify these in advance, it'll save me a lot of work when I go through the method of joints. Let's have a look at an example. So we can see here a truss, right, with 5 joints, and we can see here that joint 1, I've got an unloaded joint, right, two members, they're not collinear, so in this case, if I did sum of forces in y direction, I would gather that n14 is 0, and doing sum of forces in the x direction gives me that n12 is 0, because I already know that n14 is 0, and therefore immediately I can identify that at that joint n15 and n12 are both 0, and I can eliminate them from my analysis. Let's look at case number 2. So case number 2 occurs when we have an unloaded joint, but this time with 3 members. But what is important here is that 2 of those members are collinear. Okay, so 3 members at the joint, 2 are collinear, and no external forces. Now if we do sum of forces in x and y in this case, what we'll discover is in the y direction we have n1, a component of n1 sine theta equals 0, and therefore since theta isn't 0, n1 is 0, and that means that when I come to do sum of forces in x, I do not have a component of n1, and therefore I can see here that n2 minus n3 equals 0, so n2 needs to equal n3. So they are equal in value but opposite in direction. Now I don't know what that value is, but I know that once I find one of them, I can immediately find the other. Let's look at an example. So in this case, if I look at joint number 2, I can see that I have 2 collinear members, right? n12 and n23. They're on the same line of action. And I have one member that has a component in the perpendicular direction, in this case, in the y direction. Okay, it doesn't matter what that angle is. It can be anything. It can be 90 degrees, it can be 2 degrees, it can be 170 degrees. It doesn't matter. The main thing is it is not on the same line of action, and there is a component in the perpendicular direction. So in this case, if I were to analyse the forces in the y direction, I get that n25 equals 0. In the x direction, I can only say that n23 equals n12. I can't really tell you more than that, what the values are, but I can tell you that they are going to be equal and opposite. Now I don't have to do this every time I get to a joint like this. I can immediately identify that the member that is at an angle is a zero force member. So moving on to our last case, case number 3, this really is a subcase of case number 2. It happens when I have 2 members at a joint. There is an external load. Now this could be a load or a reaction force, but it is in the same direction as one of the members. So this is really like having 2 collinear forces, so very similar. So according to this, if I do sum of forces in the y direction, I will find out that n1, or the component of n1, equals 0, and therefore it's out of the equation for the sum of forces in the x direction, I'll only have the reaction force or the external force and N2, so I'll be able to tell that they're equal and opposite. Once again, it doesn't matter what angle theta is. As you can see here, the main thing is that the member that is not collinear has a component in the perpendicular direction and therefore has to equal 0. So now that we've gone over all these cases, let's have a look at some joints and try and figure out where the zero force members are hiding. So case number 1, can you see any zero force members here? So this is an unloaded joint with two members that are not collinear. So in this case, if I were to do the sum of forces in the x direction, I discover that N12 is 0. Doing the sum of forces in the y direction, I discover that N24 is 0. And this is how we can notate this on our truss. But essentially, I can eliminate them from my calculations without having to go through this method of joints. I can identify them immediately. Let's have a look at this case here. Do you think there are any zero force members here? Well, actually in this case, there are none. I have two cases of collinear forces and members. So if I were to do sum of forces in the x direction, I'd find out that N12 equals the reaction in the x direction, and sum of forces in y means that N24 equals the reaction in the y direction. So none in this case. How about this case? In this case, we have two collinear members and one member that is at an angle. So in this case, sum of forces in x, I would find out that N12 equals 0. And if I look in the y direction, in the direction of the collinear members, you can see I can't actually tell what the value of those collinear members are, but I can say that they are going to be equal and in opposite direction. How about here? Any zero force members? So if you've seen the previous case and guessed that this is the same thing, just swiveled around by 90 degrees, you are absolutely right. It is exactly the same thing. Two collinear members and one member, a third member at an angle, with no external loads on that joint. So if we were to do sum of forces in y, we'd obviously discover that N24 is 0, and if we do sum of forces in x, we would discover that N26 and N12 are equal but opposite directions. How about this case here? Again, it is the same subcase. An unloaded joint, two collinear members, one coming out at an angle. That member at an angle is going to be a zero force member. And we can prove it. Once again, using sum of forces in the y direction, a component of N24 equals 0. We know that the angle can't be 0 because we can see it physically, so N24 has to be 0. If N24 is 0, it gets out of the equation for the x direction, and therefore I just have N26 and N12 in that equation, right? Because this is 0, and so N12 has to equal N26. Let's look at another case. Again, any zero force members? If you've guessed no, you're absolutely correct. This does not fit in any of our cases. So in this case, if I were to do sum of forces in x, I would discover that N12 equals N26, and doing sum of forces in y gives me that N24 equals that reaction that I have there. So no zero force members in this case. So before we look at an example highlighting the advantages of identifying our zero force members, one thing that I want to remind you is when we look for zero force members, we look at each joint individually. The joint has to be in equilibrium. So even if you think by looking at the joint above or to the side or below that it can't be a zero force member because there's a force there, each joint has to be in equilibrium. So if it's a 0 at one joint, it'll have to be a 0 at another joint. So just a reminder, look at each joint separately. And when you do that, you might actually discover that once you've solved one joint, it influences another joint, just like in this case that we'll look at now. So looking at this truss here, it does look quite complicated, right? There are lots of members, there are angles, there are lots of things going on here. But using our knowledge now on zero force members, we can see that we might, without any calculations, be able to simplify this. Let's see how. So if I look at this joint here, what do I have? I have an unloaded joint with three members, two of which are collinear. The member that is not on that collinear line is a zero force member. And therefore, this member here is a zero force member, meaning that I do not need to calculate the force in it because I know that it's 0. Now, on the same scale, if I look, this is a symmetric structure, right? If I look at the other side, I have exactly the same case. So these two are now zero force members. Let us look at the truss again without those members. I've dashed those members just so that they don't interfere with our calculations. What can you tell now? Well, if you look at this joint here, you can see that we've got a joint, it's unloaded, it has two members, they're not collinear, and therefore, you're right, both of them are going to be zero. So these two are zero. Now, since again this is a symmetric structure and I have exactly the same joint on the other side, I also know that these two are zero. And now I'm left with this structure, right? So much simpler. It's just two lines that I need to solve here, right? So I went from something that would have been quite time consuming and complicated to solve to something quite simple, just by identifying the zero force members without actually doing any calculations. So now in reality, what I need to solve is that joint at the top. I can solve it, right? There are two unknowns, N17 and N27. Those are the two members that I need to solve to find out the forces in this full truss. So essentially just this joint, and we've solved the truss. So that was just an example of how this can really simplify your calculations. So just a last reminder here as we finish, these are the three cases. If you can identify them, those are zero force members and you do not need to calculate them. If you can't identify them, they will still come out as zero when you do your method of joints or method of sections. Okay, so they'll be zero in any case, but as you saw, if you can identify them, then you'll solve it even quicker. So just a reminder of the three cases. The first one is you have an unloaded joint with two members, they're not collinear, they're both zero. The second case is an unloaded joint with three members, two of which are collinear. The member that is not collinear is a zero force member. And the third case, we have two members, however, this joint is loaded, and that load, be it a reaction or an external force, is collinear with one of those members at the joint. In this case, the member that is not collinear with a force is going to be a zero force member. So I hope that was useful, and I hope that you now know how to identify zero force members in any truss that you'll come across. Bye for now.